We are heading in the same direction as our Andromeda, a large neighboring galaxy system with hundreds of billions of stars. The result of this collision will be a mutual change, affecting both galaxies in significant ways. Historically, the Andromeda Galaxy was vital in showing that we were not the center of the universe. It has been the subject of astronomy research for more than a century. Andromeda demonstrated that the Milky Way wasn't the only galaxy, altering our perception of the cosmos. Despite the fact that much has been learned, Earth innovations like the James Webb Space Telescope have offered fresh, shocking information about Andromeda that we didn't anticipate for a century. The Milky Way, just over 100 years ago, was perceived as a small light band across the night sky because the technology of the time has prevented the ability to spot individual stars. It was centered on beliefs about the Milky Way. This changed in the 17th century. When Galileo Galilei used his telescope to examine the Milky Way, he revealed that it was more than just a band of light, a vast array of stars, planets, and celestial objects. Galileo's discovery eliminated the idea that the Milky Way was the universe's center, revealing it as a vast galaxy. In 1750, Thomas Wright, an English astronomer, believed that the Milky Way was a layer of stars, including our own solar system, a theory constrained by the early technology of his time. During the 1900s, significant progress was made. In the 1920s, Edwin Hubble, an astronomer, utilized Mount Wilson Observatory's 100-inch Hooker telescope to demonstrate that distant nebulae, including the Andromeda Galaxy, were distinct galaxies containing billions of stars, fundamentally. Changing our perspective on the universe, also known as the Andromeda Galaxy or M31. It has been observed at least since the 10th century by the Persian astronomer Abdel-Rahman al-Sufi, who described it as a small cloud. Al-Sufi's sharp vision made possible his identification of Andromeda without telescopic equipment, feat remarkable because Andromeda is one of the few galaxies visible from Earth's surface without special tools. In 1612, Simon Marius laid out a telescopic description, setting the foundation for future astronomers. In 1764, Andromeda was catalogued by Charles Messier as M31, advancing its recognition. A major advancement in our knowledge of Andromeda occurred in 1864, when English astronomer William Huggins studied its spectrum, recognizing that it was not a typical gaseous nebula, a significant observation. Andromeda is enormous. With a mass estimated to be between 1 and 2 trillion times greater than our Sun's and an age of approximately 10 billion years, indicating a complex past of formation resulting from the fusion of smaller galaxies. Early astronomers believed Andromeda to be significantly larger than the Milky Way. Recent research has updated these estimates, demonstrating that both galaxies' masses are significantly closer than previously believed. The physical dimensions of the Andromeda Galaxy exceed those of the Milky Way, with an approximate diameter of 220,000 light-years compared to the Milky Way's 100,000 to 175,000 light-years, highlighting Andromeda's fascinating vastness. One of its highlights is the active galactic nucleus. It's fueled by a gigantic black hole with an estimated mass of 110 to 230 million times that of our Sun. Observations using high-tech telescopes, such as the Hubble Space Telescope, reveal 2 points of concentration in Andromeda's galaxy, with the brighter one slightly off the true center, indicating intense gravitational interactions and the existence of a massive black hole. Additionally, Andromeda has an abundance of globular clusters, with an estimated 460, each containing hundreds of thousands to millions of stars. This abundance reveals Andromeda's past of galactic cannibalism, where smaller galaxies were absorbed, bringing its stellar population up to date and increasing its diversity. Recent observations suggest that Andromeda could be transitioning from a ring galaxy to a typical spiral galaxy, a relatively uncommon variety characterized by bright, ring-like circular structures where young stars can form. Ring galaxies form through collisions between galaxies or when a smaller galaxy traverses the center of a larger one. It's making them distinctive from other galactic structures. The approaching collision between the Andromeda Galaxy and the Milky Way, a cosmic event, is expected to commence in approximately 4 billion years and will unfold over the 2 billion years that follow. This grand encounter will result in the creation of a brand new supergalaxy, formerly referred to as Milkomeda by enthusiasts and astronomers. The merging process will be defined by significant gravitational interactions and tidal forces that will profoundly impact both galaxies, including the Milky Way. As Andromeda and the Milky Way approach one another, enormous gravitational forces will alter their shapes. Stars, gas, and dust from both galaxies will be pulled by gravitational interactions, resulting in longer tidal tails and a collection of intricate gravitational interactions. The mixing and overlapping of the two galaxies will not be a smooth process, but rather one marked by chaotic and dynamic changes as their structures are slowly dismantled and transformed. One of the most significant effects of this collision will be the development of brand new star clusters. As the galaxy's gas clouds collide and compress, they will trigger a flurry of star formation. These stellar nurseries will be areas where strong gravitational forces squeeze the gas to the point of collapse, forming new stars. These newly formed stars will often be organized into clusters, adding to the new supergalaxy's value with brand new stellar populations. Simultaneously, gravitational instability will alter the orbits of existing stars that were previously in stable orbits around either Andromeda or the Milky Way. These stars may be thrown into newest, more elliptical paths or possibly ejected from the merging system, altogether becoming rogue stars in intergalactic space. This redistribution of stellar material will aid in the development of brand new cosmic structures and could result in a complex web of blended star streams and clusters. Remnants from both galaxies, as well as the formation of new stars and clusters. The merging process will also result in massive, intricate structures in the new galaxy. The dust, gas, and stars from the merger of the two galaxies will form vast areas of star creation, spiral arms, and possibly brand new galactic features that are a cross between the original Milky Way and Andromeda forms. Over time, these structures will develop as a result of the brand new dynamics of the merging galaxy. The enormous black holes in the centers of the Milky Way and Andromeda will play a crucial role. As the galaxies merge, their central black holes will eventually combine to form a single, larger, and more massive black hole at Milkomeda's core. This merged black hole will be a potent energy source, significantly influencing the stellar environment and contributing to the dynamic, evolving structure of the new galaxy. The fusion of the Milky Way and Andromeda will produce an entirely new cosmopolitan landscape. Milkomeda, the brand new supergalaxy, will be a massive entity composed of blended material from the two original galaxies. It will include a plethora of fresh stellar orbits altered by star clusters and revamped galactic features. This process of cosmic evolution, driven by the collision and merger, will shape the future of the local galaxy cluster and provide an intriguing look into the long-term dynamics of galactic interactions. The merger will result in significant modifications to our night sky and Earth's natural environment, affecting the biodiversity of habitats and the climate. However, this process will occur long after the Sun and humanity are gone, as the Sun will transform into a red giant, rendering our solar system uninhabitable in approximately 5 billion years. After Andromeda's merger with the Milky Way, this raises concerns about our solar system's fate and the creation of new galactic structures. The new galactic environment, shaped by cosmic interactions, which may include zones habitable for potential life forms, though vastly different from ours. Today, the Andromeda Galaxy will be a testament to the lively and ever-evolving nature of the universe. The collision of the Milky Way with Andromeda is anticipated to occur in about 4 billion years. It will be a spectacle of cosmic dimensions, marking the culmination of a dance of gravity that began billions of years ago. Initially, these two enormous galaxies started their inevitable approach toward one another across the vast space. As the merger advances, one of the most important phenomena astronomers anticipate is the spiral transformation of both galaxies. Currently, the Milky Way and Andromeda galaxies are spiral, distinguished by the prominence of their arms extending outward from a central bulge. The outlines of these spirals, composed of gas and stars rotating around a central core, form distinctive patterns visible from Earth. However, as the galaxies advance and their gravitational effects intertwine, the transformation of these spiral structures will involve significant adjustments. The mutual forces of attraction between Andromeda and the Milky Way will distort their forms, pulling and stretching their swooping arms into long tidal wave features. These features, composed of gas, dust, and stars diverted from their initial disks in the galaxy, will create a chaotic but captivating display throughout the cosmos. The collision's landscape will also cause rapid spurts of star formation within the brand new supergalaxy. The interaction of gas clouds from both galaxies will expand and become hotter, resulting in the formation of huge clusters of bright stars. These will become childcare facilities for stars, whose vigorous radiation will illuminate the surrounding cosmic dust and gas, conceiving new stellar populations. The merger will not only affect the galaxy's internal dynamics, but also their gravitational interactions. The interactions between gas clouds and stars will result in a reorganization of their orbits and speeds, with some stars thrown into more eccentric orbits, while others may be completely ejected from the merger system, advancing to float freely as rogue stars in the void between galaxies. In the meantime, the enormous black holes within the cores of the Milky Way and Andromeda will play a significant role in shaping the new galaxy's future. These massive beasts, containing millions of times the mass of our Sun, will eventually converge on one another, releasing gravitational waves as they orbit closer and closer. In the final stages, the black hole merger will cause a catastrophe, releasing a great deal of energy into space as gravitational radiation and waves. This merger will result in an even larger, enormous black hole at the center of the brand new galaxy, enclosed by a swirling accretion disk of gas and dust. The presence of such a powerful central engine will have significant effects on the supergalaxy's evolution. It will control how stars grow, influence the motions of dust and gas, and possibly cause quasar-like phenomena within the galactic core as matter enters the black hole and produces substantial radiation across the electromagnetic spectrum. On its broadest scale, the merging of the Milky Way with Andromeda will impact the ongoing evolution of the cosmic structure in the universe. Galaxy fusions and interactions are essential steps in the hierarchical model of galaxy formation, in which smaller structures join together to create more extensive and intricate systems over cosmic time. By studying collisions like the one between the Milky Way and Andromeda, astronomers gain knowledge of the mechanisms behind galaxy formation and evolution. By examining how gas and black holes interact during such events, scientists can test theoretical models of galaxy fusions and improve our comprehension of the underlying processes. The merger will also have consequences for the MD distribution of dark matter in the newly formed supergalaxy. Dark matter, an invisible and elusive form of matter, constitutes a substantial portion of the universe's mass and plays a crucial role in shaping how galaxies are built and their gravitational interactions. During the merger, the gravitational forces caused by the halos of dark matter surrounding Andromeda and the Milky Way will combine and interact, influencing the overall distribution of dark matter. Observing the effects of dark matter prior to and during the merger will provide valuable information about its nature and properties, helping astronomers decode one of modern cosmology's greatest mysteries. The merger between Andromeda and the Milky Way will also provide a one-of-a-kind opportunity to study the formation of galaxy clusters and superclusters, enormous cosmic structures made up of several galaxies held together by gravity. These are among the universe's largest known structures and provide information on the vast scale of both the formation and distribution of matter. As the Milky Way and Andromeda come together, their satellite galaxies, smaller galaxies that revolve around their more massive counterparts, will be influenced by gravity, becoming entangled in the merger procedure. Some may combine with the brand new supergalaxy, while others may be ripped apart and absorbed into its extended gas-filled halo of stars. The fate of these satellite galaxies will be determined by their orbits and velocities in relation to the merging Milky Way and Andromeda system. Some might survive the merger, remaining relatively intact as dwarf galaxies in the newly formed supergalaxy, while others may be disrupted and eventually incorporated into the larger structure. Merger of the Milky Way and Andromeda will also have implications for the environment of the universe surrounding our solar system. While the collision itself will not pose a direct threat to Earth, the influx of cosmic rays and gravitational disturbances from the merging galaxies could have subtle effects on our planet's climate and exposure to cosmic rays over geological time. Additionally, the development of the brand new supergalaxy Milla will produce a radically different night sky for anyone living in the Milky Way. The merger will rearrange the positions and locations of stars, star clusters, and the possibility of new nebulae, reshaping celestial landmarks and constellations that will influence the social and cultural aspects of any civilization's navigation in the far future. In conclusion, the collision and merger between Andromeda and the Milky Way will resemble a cosmic display on an unprecedented scale. It is a process that will alter both galaxies, resulting in a brand new supergalaxy that combines the 45.com.oru, the materials and features of its precursors, into a single cosmic entity. From the reshaping of spiral arms and the emergence of new star clusters, to the coexistence of enormous black holes and the redistribution of dark matter, the merger's various components will leave a permanent mark on the future evolution of the nearby cluster of galaxies. This event provides astronomers with a unique opportunity to observe the transformative power of gravitational interactions that shape the universe. It serves as a reminder of the dynamic and fluid nature of the cosmos we inhabit, where collisions between galaxies eventually produce new, persistent structures and phenomena to pique the interest and wonder of those exploring the universe.